Hey, good afternoon everyone. It's Mr. Nunez here, and today we're going to be talking about friction. And to do that, I've got a little bit of help from Lego Batman. And what he's trying to do today is he's trying to move his Bat refrigerator, which is obviously black because everything Lego Batman owns is in fact black. The problem is, if Lego Batman comes over to the other side of his refrigerator and he starts to push, as he starts to push, the refrigerator doesn't do much. So he pushes a little bit harder. The refrigerator doesn't do any more. It's not until past a certain point Lego Batman is able to actually push his refrigerator across the floor. I think I said printer, I meant refrigerator. So as he pushes this refrigerator across the floor, it seems like the harder he pushes, the faster it ends up going. Which should make sense to most of us if you've ever tried to push anything before. But then all of a sudden, Lego Batman, coming into another room of his house, has a very coarse floor. Let's say it's carpet. Okay, he's got some old like 1970s shag carpet in his house. And now he tries to push. And he's pushing hard, but it's barely moving. So he pushes even harder. And for some reason on this carpet, it's even harder for Batman to get from one side of the room to the other. Now, why he's pushing a refrigerator over carpet is largely irrelevant to today's discussion, but there is something to note between the difference between hard carpeted floor and some nice smooth floor. And it turns out we're able to solve this Batman refrigerator problem by thinking about friction. So let's look at a couple different vocabulary words as we talk about friction. Okay? So friction comes in two different forms. Okay? The first form, let me see if I can get this to focus a little bit better. The first form of friction is what we call static friction. Okay? Now, we're going to see the word static a couple times in this unit and throughout the rest of the year. And static simply means not moving. Okay? If you were going to take notes on anything for a quiz tomorrow, let's make sure that you're taking note on the things that I'm writing. So besides static friction, there's also what we call kinetic friction. Kinetic friction is what happens when things are moving. Okay? Now, static friction explains why when the refrigerator is just sitting there, Batman has a hard time pushing it and getting it to start moving. Okay? Kinetic friction, on the other hand, explains why as he moves it, you can hear that noise going across the floor. So there happens to be a difference between static and kinetic friction, and it's not just that one involves moving and the other one doesn't. So instead we want to look at the two different parts to the friction equation. So we're going to see the force of lowercase f, this is our friction equation, is equal to this symbol right here times Fn. Okay? Now this symbol right here, this is the Greek symbol mu or mu. Okay? And this is called the coefficient. Guys, I spelled that word so wrong. The coefficient of friction. Okay? And what the coefficient of friction tells us is the roughness of a surface. So this explains why when Batman pushes the refrigerator on the smooth floor, it moves across the floor very easily. But when he tries to push the same object over a rough floor, it's even harder. Okay? If you've ever tried to slide your desk across a carpeted floor, very difficult, but if you try to slide a desk, say in my classroom, it's very easy. That's because of the coefficient of friction. Now, the other part of this equation, though, is the normal force. This is simply how hard the floor is pushing up on the object. So let's imagine instead of it just being the refrigerator, now it's completely full, it has a bunch of mass on top of it. Think to yourself, would it be easier or harder to push this across the floor? Hopefully in your mind you're thinking, oh, it's got to be harder because there's a bunch of mass. And so sure enough, Lego Batman has to push even harder to get this to move at all. Okay? On the rough floor with more mass, the push gets even harder. Okay? So as we come into class tomorrow and we start to think about the force of friction, this equation can get a little bit tricky. But you have experienced the force of friction many times in your life. Trying to push heavier objects is harder than it is to push lighter objects, and that's because of this right here. And pushing objects over a smooth surface is easier than pushing objects over a rough surface, and that's because of the coefficient of friction. Okay? Now the last piece to this whole thing is what's known as the friction graph. Now the friction graph is probably one of the most, or can be one of the most confusing parts of friction, but I think that if you look closely at it, it actually is pretty intuitive. So on this side of the graph, we see just an F, and we're going to think of this as the applied force. Okay, so F applied. This is basically Batman's push. Okay, so this is how hard this guy's pushing. Over here, we have the force of friction. And so what you can see is, as Batman pushes harder, while it's not moving, the force of friction pushes back even to match his force. And we saw that. When he was pushing on the refrigerator at the beginning, it doesn't move, he pushes harder, it still doesn't move, he pushes harder, it doesn't move until eventually it starts to move. Okay? That's what this graph shows. As he pushes harder, friction pushes back to match him. But right when he goes from not moving to moving, we can see there's a steady drop in the amount of friction. And that's because the amount of friction that's applied to a sliding object is actually less than the amount of friction applied to a stationary object. Okay? Now, if this last part doesn't make a ton of sense, this is where we're going to spend the majority of class tomorrow. So just be sure that you know those vocabulary words, and you will do just fine on the entrance ticket. And as always, thanks for watching.